Welcome to Module 7. We're going to start to discuss multiviews and some very special projection called orthographic projection. Here are the following things we're going to learn in this module. We're going to talk about what is the orthographic projections. We're also going to review a way how you can create multiviews, and we're going to introduce a method called the classic box method. In the lab, you're going to prepare some multiview drawing using the projection techniques, which we will be covered in this slides as well. You're also going to create what we call the detailed views by adding lines to help you to understand how to create a multiview. We're also going to discuss the difference between the first and third angle projection, which are two different ways that people look at an object, and you have to specify where your point of view in order to give us an idea how we can present the projection. The reading and the standard related to these topics are the following. You can read the chapter 10 of the electronic PDF file textbook, and the paperback textbook which we use the most is on chapter 3. Chapter 4 will tell you about how you can create a multiview in AutoCAD, which we will be covered that in the next module. Here are the standard. The ASME standard and ISO standard also give the instruction how you can create these things based on some protocols. First, let's understand the projections. Well, the projection is a view of an object. And how can we define a projection? Well, you need three different things. So over here, we show you like two different kind of projection. You can have what we call the perspective projection. You can also have a way called the parallel projections. And the difference between these two is for how you look at the object. But it doesn't matter how you look at that. You always have three different things you have to include in the projection. One is, what is your stationary point? Where you observe the object? So you should have a place to tell us where you look at the object. The second thing is, what is the plane of the projection that you placed at? So you can see on both of the cases that we have the plane either at this place or in, and you can place it at, closer to your eye or further away from your eye. That will give you a different kind of projection. The third thing is, what are the projectors? The projector meaning the ray of the light that you use to project the object, such as the parallel one. If you look at the parallel one, you can see all the lines is in parallel with each other. And perspective or different projectors because they all oriented from the eye. They're not parallel to each other. That's the main difference of these two kind of a way of doing the projection. So we just introduced like two type of projections, perspective and parallel. Actually, there's a big family of these two type of projections. As you can see in these pictures, you can have a linear perspective, an aerial perspective, and there's a lot more for the parallel as well. But one thing we wanted to show you is that we are only going to focus on one kind of projection, which is this multiview projection. The rest of them is what we call the pictorial. So you can see the difference by just looking at them. For the perspective projection and or part of the parallel projection, they all present the object in the more like a three-dimensional way. right? So you always have the line go into the depths to show you what the depths that is. However, for the multi-view, you only look at the object in a two-dimensional. So that's the main difference between what we call a multi-view and pictorial. Pictorial is more like a three-dimensional view of a picture. So only the multi-view shows the two-dimensional, but the rest of them all look like a three-dimensional. You need to keep in mind, a three-dimensional, even though they represent three-dimensional, they still draw on paper, and paper is two-dimensional. You just use different angle to look at the object to create this kind of an imaginary three-dimensional look. And each one of them just using a different point of view or different way to project the image on the plane. So let's start with the orthographic projection, which is the main focus of this module. An orthographic projection is to draw things in which is a three-dimensional item, but instead of drawing a three-dimensional, we use the two-dimensional drawings to represent a three-dimensional object. And this is a topic about the descriptive geometry, which we will not go into the depths of this. It simply just tell you how you can describe an object and using a graphic way. Here is an example. You have a three-dimensional object, look like this one over here. And if you put a plane in front of the object and you try to project the object onto the plane, and the thing that you can see is only this side of the object. So this is called the orthographic view because for each one of the view, they are perpendicular to each other. Then when you do this kind of projection, the plane is what we call the plane of the projection. And the view is what we call the orthographic view. So these are some kind of terminology that you have to remember. And when you project that, when you present it on paper, it will be like the bottom part of this one here. It shows you what you actually look from this point of view and what it will be presented on a plain paper. Sometimes when you look at the object, if the plane that you're looking at is not simply just parallel to your plane of projection, for example, the object that we have in here, this side of the plane, which is not parallel to your plane, while this side is parallel. So you have to be careful when the thing is not parallel to your projection plane, the plane of the projection. The actual size that you see from this plane or this drawing is not going to be the actual length of this side, right? It's actually shortened. Whenever you have a plane which is not parallel to your plane of projection, the length will be shortened, meaning you look at this length over here and this length here, they're different lengths. This one is shorter and this one will be longer. So when you draw a multi-view, let's introduce what is a multi-view. A multi-view meaning you have several different views, and what are the name of those views? On this picture over here, we shows you a pictorial, and we also show you the multi-view. The pictorial is more like a three-dimensional. The multi-view are the combination of two-dimensional drawings. So multi-view drawing represent three different kind of views by looking at the three-dimensional object from different perspective. And you will represent the shape to describe this object by using three different kind of views. It is not necessary always include 3 different views. As we go on, you will see sometimes you just need 2, sometimes you just need 1. And it depends on the object. Now the way to see how we can visualize an object into different views is by using a method called the glass box visualization method. The way to think of this is very simple. You think about if you put an object inside of a glass box. So all sides are transparent and you can see the object from each one of the sides. And by putting an object inside this box, if we can shine some light to make the object project to each one of the sides, then we open it up, then you will have this kind of pictures to present the object in different face. Each one of the face is what we call the view. So there are totally 6 sides, right? 6 sides, and we just give the name to different sides. You're gonna have a front, a top, 2 sides. One is on the right, one is on the left. You also have a bottom, and the rear is the one behind the front. So there's like 6 different kind of a view. So this is what it looks like. The glass open method. The object is inside a transparent box. If we open it up, and before you open it up, you project the lights and you will see from different perspective, you're going to see different shape. And the things behind the plane, you cannot see it. And that's why when you look at this box over here, some of the line are solid, some of the line are dashed. When you make the drawing, we will talk about different kind of lines later, but one of the first thing you're going to learn is if you can see the object, if you can see the line, and those line is what we call the visible line. Let's use this one as an example. Over here, if I look at this view over here, you can see this one here, which is like almost like an L shape, is like an inverted L shape. The edge of these objects, like this one here, they are all visible. The top line represents this edge over here. This one here represents this thing over here. Okay, and you notice that we just talked about this. This plane is not parallel to your projection plane. So this lens actually is longer than this thing that you can see over here. So this one is a shortened lens. And what else? This one, you can also see it is on this side over here. And this one here is this one here, and this one here is this one here, and so on and so forth. What is this one coming from? How can we have this one dashed line over here? Well, this dashed line is actually the line at the edge of this arc. This is like a semicircle arc over here, which you cannot see it, but there is a line over there to represent the edge of this arc. So this is what we call the hidden line, meaning if I can actually kind of penetrate, the line penetrate, I can see this one here. There is a line will show up from there. So that's the hidden line. Let's think about what are the things you have to be careful when you do this glass box method. The first thing is that you notice there are several different projection planes. They have different names. Just be careful what they are called. The second thing is, what is the projectors? With the projectors, meaning that you shine the light, and those are the light rays. So how do you shine the light, where it comes from, is important. And the third thing I wanted to remind you is, again, sometimes if the plane is not parallel, then your area or the dimension on the multi-view is going to be different from the actual object length. For example, if you look at the plane of B over here, this one represents this plane at here. The actual plane is actually larger than the projected. So keep in mind, the dimension on the multi-view might not actually reflect the actual one. You have to look 3 different views in order to understand what the actual object looks like. Let's quickly kind of show what the 6th plane looks like. So give you a quick idea how we actually present this one in 6 different views. So initially you put an object inside of the box, you open it up, and you can display the object in 6 different planes. Each one of the planes has a different name. And so let's do a quick exercise to recognize what are the names of each one of the planes. So we have the first one is called the front view. The front view is that you look at the object, and the object, the face of the object is the first view that you see, is what we call the front view. If this one is the front view, then that's then the rest of the view. So what do you think on this one here represent? Here the front view represent this one here. And what do we know about this? This one represents this one here, and that should be our top view. Then what about this one here? And you look at this one here, this is exactly the view over here. And that's one of our side view. And this is what we call the right side view, because you look from this point, and that will be on the right side. What about the next one? The next one is more like the view over here on the back of this object. So that's what we are rear view. And the next one over here is another side view, and that's what our left side view. And the last one here is at the bottom of this object, which is what we call the bottom view. So what's the difference between the right side and left side? If you compare these two, you can find out there is simply just the mirror image of one different type. So they're just very similar, but they're like a mirrored. Same thing from the top and bottom, and you're going to see they are also the mirror image. So when you make this kind of a line, and we also wanted to choose certain views, so we have a minimum amount of the hidden line. So if you look at all these, which one will give you the least amount of the hidden or the dashed line? The hidden line is the dashed line. Well, and as you can see, the front and the top doesn't have any of the hidden line, meaning the thing that you see are the actual line, and there's no hidden at all. Okay, after we discuss the glass box visualization method, I'd like to show you how we can actually create these views. If you have an object that is 3-dimensional, how can we create all these views? Are there any techniques that we can use? Currently, we're using what we call the third angle projection. We will discuss this later. But the method that you can create these things are very simple. The one And the method we're going to introduce is actually what we call the MyTree line. The MyTree line is the method that, which is this example over here. The MyTree line tells us a relationship between different views. If you look at here, we have this view, what we call the front view. We also have an object over here, which is called the right view. And there's another thing on the top is what we call the top view. So if you include these things is what we call a multi-view. If you are doing a the third angle projection. So when we ask you to do a multi-view, we have to draw these three different views. But as I said, depends on the situation. You might just need 2 or 1 views to show the object. But in general, you have to have the 3 different views. When you draw this object, normally we start from the front view. Once you have the front view, the next thing usually we will do is either to the top view or the side view. The MyTree lines help us to get the last view to finish the drawing. And the idea is this. If you start with the front view like this one over here, and then you create a top view by looking at the object, then you draw a 45-degree line over here. This line is what we call the MyTree line. When you draw a 45-degree line, and where is the 45-degree line start with? The 45-degree line start with like if you treat the object like a rectangular, and at this corner over here you extend the line along the 45-degree, and this is what we call the MyTree line. If you have this MyTree line, what happens is the real object is going to have a 3-dimension, and that 3-dimension are related by this 3 different drawings. Watch here. This length of the front view is going to be the same as this one on the top view. And also, if you look at the height of this size, it's going to be the same as the height of this side of the view. But it's not going to be the same as this one over here. This one is not the same as this one here. But this length will be the same as the width of this one over here on the side view. So their dimensions are related, and they're related in this way. And you can use the 45-degree line to project the length, and especially from the top view to the side view. So the way that you do it is you make the parallel line from the object, say for example from the front view, the top view, make it horizontal. All these lines, when you have a turning point, make the horizontal line and make it go connect with the 45-degree line. Once you have the intersection, then you go straight down. When you go straight down, it will help you to locate where you should have your side view, and it will also give you the dimension directly, that you don't need to figure out or worry about where my object should be located and where the line should show on the screen. Let's give you an example to show you how you use the MyTree way to create multi-views. The first thing you have to do is, once you are given with an object, the first thing you have to decide is actually where is my front view, because you have 6 faces. Which face should I use? as my front view. There is some like a rule. The most important rule that you will choose is when you look at the object, which side will give you the most of the feature. When I say feature, meaning which side will show you most of the detail. Because if you can see the face with most of the detail, then they will not be hidden. Because when they are hidden, you're going to use the hidden line, which are the dashed line. But we prefer to see things in the visible line, that we can actually see where you're going to have the turning place, where you're going to have like a hole, where you're going to have some different lengths or width of the object. So choosing a front view is the most important part. Let's say we choose this one as our front view. So we are actually use this plane as our front view. So this is our front view. Then you start to look at the front view and you draw the front view. And what does the front view looks like? It's very obvious, right? Now, how many views do we need is the second question you have to ask. Do we need 3 views, or we just need 2? Or do we just need 1? In this case, we actually just need 2. And because if you look at the view on this side over here, it doesn't really shows any of the feature that you need. If I only have the top and the front, I can fully describe this object. Well, you probably won't see it right now, but in the future, once you practice this more, then you will see this plan of the view is really not necessary. But for the purpose of showing you these techniques, we're going to actually draw 3 views in this example. Okay, so let's make the front view first. The front view is very obvious, as I said, and you just need to look at this side of the object, and this is your object you try to draw, right? And you kind of transfer that projection plane into the paper and put it at this corner over here. This is the third quadrant of this paper. And this shows your front view. Now all these lines you can see, so they are all solid lines. They are visible lines. Once you finish that one, and usually we will make some like a construction line, what we call the construction line. The construction line are like a guiding line for you to locate where your line should go along, at what direction, and also you can use those directions to figure out the length of the line. So whenever you see a turning point, you should draw the construction line. These dashed lines represent the construction line over here. Okay, or we can call these the projectors. Like you actually have a line go through, and where are the object that you can see. And after that, then you can start to draw your top view. If you are given with the dimension, let's say this is 7 by 5, and then you know the 7 represents this side here. This is the 7, and this will be the 5. And if you are using the AutoCAD, then you should familiar with how to use the line command to draw a line. You choose this point as the starting point of your line, and you specify 90 degree with the length of 5 will give you this, right? Or you can simply use the rectangular command to create a rectangular with the dimension of 7 and 5. And you notice the second line that you coming from the bottom, the front view, it will also give you a line on the top view. But this line is a hidden line because this is the line actually at this turning point where from the top you cannot see it. But there's a line at the bottom over here. So this is the hidden line that you actually see represent this one over here. Same thing on the right hand side, you also have a hidden line and they line up perfectly. You don't need to figure out where they is. If you draw this construction line, it will show you where they are. You also have a circle that you can see from the top, right? So that is the thing that will show you as well. Now, once you finish the top view, you will see, wow, it's very interesting. I have an object over here, and they should be also related to your front view. So if you project these two circles of the edge and project that down, you were supposed to have a hidden line to represent the circle, the edge of the circle, which are these two hidden lines over here. And that's the beauty of using this kind of a guiding line to help you to draw the object. The next thing that you wanted to do is to find the right side view. And to find the right side view, the best way is actually use the Maitri line, which is a 45-degree line. So you make a 45-degree line, then you transfer all this horizontal line and vertical line by looking at from the top view where am I going to have some turning point. So this is the side of the top, this is the side of the bottom, this two are the sides of the edge of the circle, and they will intercept the 45-degree line. Then you project them downwards, so these lines are projected from the 45-degree line. At the same time, you have some projection line from the left, so all the turning point you should have a line, so the three lines represent the one from the left. Won't you agree on this side over here? I'm kind of help me to know what I should draw. If you look from this side, you know this is just like simply just a rectangular, and where the rectangular should be and what is the size of that. If you make these lines, that's very obvious. It should be this boundary. And you also have some hidden line too. And these lines to help you to find where those hidden lines are. Right? Don't forget about the hidden line. Those are the most easy mistake people make if you didn't draw the hidden line. There is another kind of line is what we call the center line. The center line tells us you have a circle. So if we didn't draw the center line, then you might think that it's just simply a cut off part. For example, this part over here, if I didn't draw a center line, you probably won't think this is a circle, but it just simply just a cut off, like a rectangular cut off parts. So we use the center line to represent it as a whole and as a circle shape object. And the center line is represented by a long, short, long dash. So hidden line are just simply dashed line. The center line is the long, short, long dash. We will introduce more lines in the future, but just remember these three different kind of line. All right, so quickly review that we just said before. The lengths, they are related. The top view, this one is the same as the length over here. This side over here is the same as this one over here. This is something that most not obvious to the people. So this one here is the same as this one here. The last thing we want to talk about is the projection. So in the States, we do things different from the rest of the country, rest of the world. We use what we call third angle projection. We look at the object from the third angle. So when you draw that, you need to have these three different views. And on your paper, when you make a drawing, if you make this symbol on your sheet, then people would know this is the third angle projection. The main thing you wanted to notice about the symbol over here is that you're starting like a cone shape with a short radius to the large radius. That represents the third angle projection. If I use another kind of a projection, which is what we call the first angle projection, and you will notice the short side is on the other side and you have a long radius on the left. And you are drawing in this way. This is what we call the first angle projection, and you are actually using the other three different sides to be your front view and side view and the top view. And these are the methods they use outside of the United States. You have to know these because you are probably will draw things for the rest of the world, and they use different way to present the object. How do we represent the angle of the projection? On the paper at the lower right bottom, we have a place called the block, the title block. Usually you're going to have a place that you're going to represent the angle of the projection, and you simply just put the symbol. The size of the symbol, the height, the width are all specified, as you can see from the previous slides. I just want to remind you these, when you actually make a drawing, you have to specify the angle of projection and put it into the block. Then make sure that you use the right symbol and also use the same dimension specified by this international standard. Okay, let's review what we learned from this. We talk about the projection. It's just simply a representation of the object. We also talk about two different types of projection, depends on how you project the line. If you project the line from one stationary point and going outwards like a ray, it's going to be what we call the perspective. If you project a line all in parallel, that is the parallel projection. And there's several different ways that you can project the object. One of the family in the parallel is going to give you a multi-view. The rest of them are pictorial. We talk about how you can use the matrix lines to create multi-views. This is the most important part. You have to do some practice in the lab. We also talk about the first and third angle projection. In the US, we use the third angle projection. So you have to draw the views in the three different quadrants. Okay, so front view at here, top view, and side view. And that's the most important part that we learned at here.